Good morning, everyone. Can you please confirm that you can see me and the light board behind?
Yes.
Yes.
You can see me, right?
Yes.
Yes.
Okay, great. Thank you. अवश्य मत न
Okay, video.
Okay, good morning, everyone. Let's get started. So before I start my talk, I would like to just introduce the Computer Engineering Seminar Series. So this was an initiative initially proposed by Dr. Samarakon and some others in the department to basically do two things. One is, share whatever expertise the staff, the instructors, and hopefully in the future we'll have guest lecturers as well coming in to share their expertise about various industry topics and the research in the case of maybe postgraduate students, the research that they're doing and so on, right? And staff as well. So the idea is to have like a completely open forum where we can share our expertise with each other, tell each other about what we are doing, not just finished, completed, final research, but even research that's still ongoing, right? To talk about it, get ideas from other people, get feedback from other people, and collaborate and improve both the research and the teaching in the department. Right? So this is the general idea behind the Computer Engineering Seminar Series. Right? And just a moment while I clean the other side of this. And in the future, we will have talks already. Dr. Alavatugoda has volunteered to do a talk about the security research that he's doing. Dr. Sandrigama has volunteered to do a talk on intellectual property. I'm hoping to get people from industry as well, experts from industry, to talk about various topics in the future. So today, I am going to tell you a little bit about the state of the art in software deployment and operations in industry, right? And let me tell you a little bit about the motivation before I get into the topic as such. Let me tell you a little bit about the motivation for the talk. We all know that when we go out to industry, right, there are various kinds of roles, right? Not just for computer engineers. If you take any discipline of engineering, you get various kinds of roles, right? And as I said in my synopsis, broadly, you can categorize these roles as doing design and development, right? Designing and developing new products is one aspect of it, but there's also the other aspect where you actually run a system, right? And in the case of software, this is known as running systems in production, right? And it's familiar to people in other engineering disciplines much more than to our students, I think. There is a bit of a blind spot where in our field, it's not so clear what people do when you mean they are handling production systems or working in operations is another way of saying it, right? So if you take electrical engineers, it's quite clear what they do when they're doing operations work, right? Which is they'll be running something like a power station, right? Maybe the distribution grid, maybe a telecom system at a telecommunications provider, right? And for our students, I think the most familiar example would be working in a network operations center, right? So when it comes to operations work, I think most computer engineering students think that it is exclusive to network operations only, right? But in reality, that is not the case, right? Network operations is just one aspect of operations. There's a whole other field of operations related to software, right? So if you take the industry in not just in Sri Lanka, but worldwide, if you take the industry, we can see maybe three kinds of organizations, right? The first one, I will call them pure development organizations, right? So pure development organizations are organizations where you have an external customer for the software that you're developing. They give you the requirements, right? In some cases, they give you the design as well. Depending on the kind of relationship you have with the customer, you may get the design from them as well. But basically, you build software to somebody else's requirements. You hand over the software to them, right? They may do some quality assurance checks on their side. And then once that's done and they accept that the software is fit for purpose, right? That you have fulfilled the obligations of the contract, then it's no longer your problem. You just hand it over to the customer and the customer takes care of the rest, okay? So in these kinds of organizations, you don't get really any operations work, right? It's a pure software development organization. In some cases, not just software, but even hardware. In the case of embedded systems, right? You develop a hardware module together with some software for it, and then hand it over to your customer, right? Who's going to actually sell the product and run it in production, right? Another kind of organization would be the pure operations kinds of organizations, right? And these are typically things like banks and big financial institutions. Even if you take the University of Peradeniya, educational providers like the University of Peradeniya, I would categorize them under pure operations organizations, right? What do I mean by pure operations? Meaning that we don't do a lot of software development. We may build small things or maybe develop our own website and so on, but we are not in the business of actually developing software, right? We let somebody else do that. So we don't actually develop software. We basically let somebody else do that for us. In the case of University of Peradeniya, let's take an example. We have the fields learning management system which runs Moodle underneath. Moodle is a learning management system that's open source, right? So we didn't develop that learning management system. We took somebody else's learning management system and we put it in production for the use of the engineering faculty, and for other faculties, we have similar setups, right? So if you take organizations like ours, like the Network Operations NCSU in the University of Peradeniya, we have a pure operations kind of organization, right? And finally, we have organizations that are hybrid between the two, which I'll be focusing more on these kinds of organizations today, right? To me, working in an organization like this has a certain advantage, right? Because you are exposed not just to software development, not just to operations, but to the entire life cycle of the software. Okay? And the best examples of these are two kinds of organizations. They're not mutually exclusive, right? The first is if you have any kind of startup nowadays, right? Maybe not all startups, but yeah, software-oriented startups, right, are almost all in this category, right? And there is a reason for that. And the reason is that nowadays we have not products, right, but services, right? So whatever thing that we build is almost always offered as a web application. In other words, a software as a service, right? And I think this is clear to everybody, right? So once you offer your software as a service, right, you are not only responsible for development, right? So development is just one part of it, right? Once you develop the software, you put it in operations, and that's not the end of the story, right? So this is actually a cycle where you put things in operation, right? Once you put things in operation, you might encounter certain bugs, right? And the operations people will inform your development team about those bugs. They may make bug fixes, push back to operations, right? The development team may develop new features, right? As the requirements grow, as your customer base grows, right? And in turn, they may push to production, where the operation team takes care of it, right? And in some cases, let's say there are requirements coming from the operation team itself, right? For instance, let's say your product suddenly becomes really popular. Okay, everybody wants to use it around the world, right? And you're getting from a couple of hundred requests a day, you're getting thousands of requests a minute now, right? So that obviously means, yeah, the operations have to scale, right? And we'll talk about these things in more detail as we go on. I just want to give you a high-level overview how these two parts of an organization interact, right? Now, traditionally, we've had this very strict separation between development and operations, right? So the joke in organizations like this, where we have development plus operations, the joke used to be that the development team will make something, right? And then there's this big wall, there's this solid brick wall, right? And then they'll throw it over the wall to operations. And then these guys have to take care of the rest of the thing, right? And this was true until the mid 2000s. This was typically how organizations that had separate development and operations arms, or both development and operations arms, there was a strict separation, right? And there was also a lot of tension between these two guys, because these guys want to maintain reliability, right? And therefore, reliability means they need to be conservative, right? Which means anytime you want to do an upgrade, right, these guys are going to be really, really careful about what that upgrade is going to do to production, right? You have a production system, you have customers, right? The customers may be internal people, they may be external, depending on your organization, right? Now, for instance, the NCSU, we don't serve external customers, right? the customers of the NCSU is the university population in Peradeniya, the members of the Peradeniya University, staff and students, right? So you may have internal customers or external customers. It doesn't matter, right? In the end, you want to offer them a reliable service, right? If fields goes down, we can't really do our work, especially now. So the ops people are traditionally very conservative people, right? Whereas the development people, they are always working on new features, right? So they like to experiment, right? They may want to try new features, new technologies, and so on, right? And you see this a lot in when we talk to our students, right? Anytime they want to build a new project, right? You'd like to try out a new technology, React Native, Flutter, whatever it is, right? You want to try the latest and greatest technology. And that means you want, yeah, quick releases, right? And there has always been this tension, right? These guys want slow release cycles, slow, stable, reliable, right? And these guys want quick release cycles where they can try out new technology and push new features into production, right? So what happened is in the mid 2000s, there was this movement to say that, okay, this barrier between this is really harming organizations. It's not good for having a smooth IT process. And therefore, right, they said, okay, let's not have this strict separation. Let's combine development and operations, right? And they came up with this term called DevOps, right? So on the one hand, this means that the development team, right? The development team have more say in the operations, right? More say in the operations, meaning, right? They have to take more responsibility for deploying their software in operations, right? If something breaks, typically, the development team in the past, right? When they had this model where they throw the software over the wall to the operations team, they were not responsible, right? The operations team has to be on call and handle any problems, right? But now the development team is also involved in operations, right? And similarly, the operations team also has some say in development, right? So maybe the operations team, right, knows MySQL really well, right? They have a lot of experience operating MySQL in production, right? And dev says, okay, no, we want to use Mongo, right? And the operations team can say, no, we can't do that right now, right? Because we have good experience with MySQL, right? So please continue using MySQL for the time being, right? Until we develop some experience running Mongo in production, right? So you have now, right, not a strong wall between the two, but some constant negotiation, right? And communication, open communication between these two parts of the organization, right? Where the development team influences operations, right, on the one hand, and takes responsibility as well. And the operation team can influence development decisions, right? So this was basically a broad introduction to the whole field of software operations, where it fits in, right? So I talked about these three kinds of organizations. In this kind of organization, the strict division between labor, right? And now within the last 15 years, the combination to give us DevOps, right? In parallel to this, there was another movement. Okay, in parallel to this, so the first movement that kind of drastically changed operations is this movement of DevOps, right? And often when people think of these things like DevOps, they think in terms of technology, right? So they think in terms of things like continuous integration. I will explain all of these terms, right? And how to use GitHub for these things and so on, right? But I want to emphasize that here, when it comes to DevOps, it's equally important to have this cultural shift, right? And if you read a lot of the seminal DevOps books, right, they will emphasize always this cultural shift where you have open communication, especially between development and operations, right? So on the other side, when it came to large organizations that were running cloud-based systems, right? The internet giants, Facebook, Google, Amazon, Apple, Microsoft, these kinds of organizations, Netflix, and so on. So these organizations basically developed a parallel, let's say, philosophy, right? Or a parallel track of bringing operations into the 21st century, right? And this went under the name of site reliability engineering. So site reliability engineering, or SRE, right, is a term basically coined by Google, right? Google were the pioneers in site reliability engineering. They wrote a really nice freely available book on site reliability engineering, which details all of their SRE practices, right? And I will talk a little bit more about that further on in the talk. But what I want to say about site reliability engineering here is that the idea is you switch from traditional, the sysadmin role, right? So what is the sysadmin? You think of somebody who's sitting in front of a computer, right? Typing commands in a Linux terminal, right? So there's an Ubuntu box and this guy is typing commands on a terminal, right? So this is the typical, the wrong notion of a sysadmin, right? So maybe students also still have this idea that a sysadmin is a guy who's sitting in front of a Linux terminal, right? Or you SSH into something and keep typing some commands, right? So the idea of SRE is that you move away from this idea of operations, right? In the case of companies like Google, they simply can't do this, right? They have millions of machines. There's no way you can SSH into each one of them and manage them individually, right? So they develop internal systems, some of which they have open source now, right? Which manage these millions of machines. And the focus is really on things like automation, right? So if you want to deploy some software, right, especially when it comes to deploying software, right, also for other tasks, you rely entirely on an automated system, right? You never ever go and log into individual machines and try to mess around with them unless you want to debug a problem, let's say in production. Okay, in that case, maybe will be allowed access, but regular operations rely on a lot on automation, right? And the other pillar of it, right? There are so many ideas here, right? The second idea is observability. Okay, I will talk more about that later on. But the basic idea is that you don't wait for somebody to call you and tell you, your site is down, right? Or your site is too slow. Your site is working, but it's too slow, right? Or your site works, but every once in a while I'll get a 500 error message, right? Once in a while it happens, right? I'm using your app and yeah, it works fine most of the time. And suddenly I start to see these error messages, right? So nobody is going to call and tell you these things. There's nobody watching to see that these things are happening, but there is a system in place, right, where your application has to have built-in what's known as telemetry, right, which will provide the information to the operations people saying that something is not working right? And so these are the technical side of things, right? They're relying on things like automation, observability, and the DevOps guys do pretty much the same thing on this side, right? They are not going to manage things by hand, but rely more on automation and so on, right? I will talk about some other things like infrastructure as code, right, later on in the presentation. So this is the technical side. On the cultural side, also the SREs invented certain things, especially at Google, right? And they put it under the phrase eliminate toil, right? Right, which ties back to this thing. Eliminate toil meaning don't do the same thing manually twice, right? If you have to do something more than once, automate the thing out of existence, okay? The second idea that they came up with is this idea of error budgets. Right. So the idea here, this is very, very important, right? This idea of error budgets is really important because this is something that a lot of our students, I feel, don't understand, right? You can't have any system that is engineered, not just software, but any system that is engineered is eventually going to fail, right? That is almost certain, right? At some point, you will see a failure. What we want to do is minimize the failures, right? We want to minimize failures as much as possible. That's all we can do, right? When it comes to operating systems in production, be it software or some other kind of engineered system, right? So the idea of error budgets is to be explicit about, right, what amount of downtime and other quantities you are willing to tolerate, right? And these are specified in terms of service level indicators. Service level indicators and objectives. So what is a service level indicator? A service level indicator means, right, the most common service level indicator that I'm sure most of you might be familiar with is this idea of uptime, right? So I want my website to be up, right? Whatever up means, right? You have to define up as well, right? So it can be up and malfunctioning, but yeah, up means usually up and functioning, right? I'll say 99.9% of the time. Okay, so that means for a day, I can have, what's my error budget? I can have 20, so this is my service level objective, 99.9% uptime, right? People commonly call this 3 nines, right? 3 nines of uptime. That means how much downtime can I have? I can have in a 24-hour day, right? This many minutes of downtime. Okay, and this is very important, right? You are allowed to have this much downtime. Okay, and then the site reliability engineer sits down and decides how best to achieve this, right? So this is the basic idea behind defining service level objectives, right? The management, who decides the service level objectives? Somebody in a management position, right? In a technical management position, somebody decides, okay, I'm willing to tolerate this much error in the service, right? How you decide that is basically a business decision, right? How important is this service to your company, right? Are your most important customers using this, your biggest customers, right? Or is it the product with your biggest customer base? Is it the one that brings you the most revenue, right? Depending on these considerations, you decide on an error budget, right? Such as for uptime. right? Or rather, sorry, not an error budget, but a service level objective, right? You can have other kinds of service level objectives, right? Another common service level objective relates to latency, right? So it's commonly known that people get really annoyed if your website takes more than, let's say, 1 second to load, right? People have done studies on this and confirmed that after about 1 second, if your website doesn't load, people will just, unless it's absolutely essential for their work, right? Even then they will be very annoyed, right? If it's some other website and you have potential customers coming to your website, if your latency is greater than 1 second, right? Or yeah, 800 milliseconds, some people quote, right? They'll go away, right? So you could say that I want a latency, or your service level objective is I want a latency of, let's say, 500 milliseconds, right? For 99% of my requests, right? So the 99th percentile latency should be 500 milliseconds, right? Only 1% of the requests are allowed to exceed this, right? So what have we done here, right? We are not saying our service is 100% reliable. This is a lie, right? If any engineer tells you this, it's a bald-faced lie, right? Instead, we be honest with ourselves and we say, okay, this service is going to fail sometimes, right? This is what we want to target, right? This is where we want to get the reliability to, okay? And this may be a negotiation with your business team, with your management team, with your developers, right? Maybe the software is badly written and it's falling over all the time, right? And the operations team cannot achieve this kind of error budget at the moment, right? So then they need to sit down with management, sit down with the development team, and decide, okay, how are we going to get to this target? Right. Okay, so on the one side, we had this DevOps movement combining development and operations. From Google and the other internet giants, we had this movement of site reliability engineering, where we start to eliminate toil. On the one hand, don't do things manually anymore, and we are explicit about these error budgets by defining service level objectives. Okay, so this is basically the first half, or the introduction to this subject. So I would like to pause for a few minutes and ask the audience if they have any questions. I would like to have a discussion at the end. We can have time for the discussion at the end. But if you have any questions about any of the concepts that I talked about right now, you can ask. You could also type your question in chat if you like. Okay, now in the second part of my talk, I would like to talk a little bit about the technical details of how we achieve some of these things, right? In particular, I'd like to talk about the technical details of two things, right? The first is automation. Okay. And as I mentioned before, we have now this cycle where developers are constantly pushing new releases to production. And in turn, the operation team may give the developers some feedback. They may also be receiving feedback from outside, right, regarding features and bugs and so on, right? So there's this constant cycle. And you may be surprised to know that some organizations, right, again, the big giants like Google, Microsoft, Facebook, and so on, they are pushing new updates to, Facebook, LinkedIn, these kinds of sites, highly trafficked sites. They push new versions to production a couple of times a day, right? So we have several releases. I remember a time when a new release of a software, right? Let's say Microsoft Office, would take a couple of years, right? You have Microsoft Office 2007, let's say, and then 3 years later you have Microsoft Office 2010, right? And now they have Office 365. You may not notice anything different, right? But within that day that you have a document open, Microsoft may have actually updated Office 365 without you even knowing about it, or Google Docs or whatever it is, right? So given this scenario where we have this rapid release cycle, there's no choice but to automate, right? There is no way out of automation, right? It's the only choice. So what happens here, right? So first of all, we have our version control system, right? And more often than not nowadays, what is our version control system? It's Git, right? And I need to give you a little bit of background about, for those of you who may not be too familiar with Git, to just give you a high-level background about how Git is typically used, right? So we have, actually, this depends on various organizations, but basically we have a master branch, right? And then we have development branches, right? We may have development branches for features, F1, F2, and so on, right? And then we have, at the same time, we may have bug fix branches, right? B1, B2, and so on, right? Each of these branches are individual versions of the software that are being developed by various members of the development team, right? Okay, so we have various branches developed by different developers, right? Each one is working on their own individual branch. When they are ready, what do? They do a merge, right? There are various ways of doing this merge and so on. I won't get into the details, but basically they combine their work with the master branch, right? When they're ready and they're sure of that everything works, right? This feature works okay, right? Or this bug fix is okay, they merge it into their branch, right? Now, one important question is, how do they know that this thing actually works correctly? Right? That is really important, right? So in the traditional answer to this question is really bad. It's a really bad answer, right? Is it works for me, right? So when you push to production and your production system is broken, you say, oh, I tested it on my machine, it worked fine, right? So that simply doesn't work, right? That's, let's say, organizations have long ago moved past that practice, right? So how do you avoid this it works for me problem, right? And the solution to that is what's known as a continuous integration pipeline. Okay. So what does a continuous integration pipeline do? Right? It builds an environment, right, in a clean environment. I won't go into all of the details of this. I'm just telling you at a conceptual level what it's doing. In a clean environment, right? It builds your branch, right? You're ready to commit feature F1? Okay. Right? Commit your branch, right? Don't merge it to master yet. Commit your branch to the main repository. What will the continuous integration system do? The pipeline, right? It will notice, you pushed a new branch, right? I need to test this and make sure that nothing is broken, right? So what it's going to do is it's going to run a build in a clean environment, right? First of all, right? And if that fails, it will give you a list of error messages, right? Hopefully you built the software on your local machine and made sure the build is okay, right? And then it will run your test suite, right? And these are not just unit tests, right? I want to emphasize this. This is not just unit tests that you can run on your machine, but rather, right, integration tests and system tests on the entire system, right? In this clean environment. This is also very important to avoid this problem of it works on my machine, right? So there are many ways to get this clean environment. Nowadays, the most popular way to do this is a technique known as containers. Right? To build the system, it may do other things, right? It may resolve all of the dependencies, right? Your system, depending on how complex your system is, almost anything that we build nowadays relies on third-party libraries and so on, right? It's going to pull in all of these libraries, right? There may be conflicts with these versions, right? There may be some problems here, even though your code is okay, your dependencies may not be okay, right? All of these things are checked by the continuous integration system, right? Once the continuous integration passes, right, you may have other manual steps such as code review and so on, depending on your organization, right? You might have a review step. Right? And finally, you do the merge. Right? You merge to your master branch. Right? Now, we can automate yet another step. Right? So we've automated this step. This is the most basic step that you can automate in your software development lifecycle, continuous integration, right? It's almost considered essential nowadays to automate this step. Right? Then once you've done that, you can go to a second step known as continuous deployment. Right? What does continuous deployment do? Right? Whenever you merge something to master, right? And once you merge something to master, there may be other tests that run, right? Your continuous integration system. Once you do the merge, you may go back here and run even more tests, right? Maybe you don't run all of the tests here for other branches because it's too expensive, right? In some cases, your software, the number of tests may be in the tens of thousands for large systems, right? So it's too expensive to run all of the tests, right? Especially the system tests, then the integration tests are expensive to run. So it may not do it for all branches, right? But only for the main branch, right? So once you merge, more extensive tests may be run by the continuous integration system. Anyway, at some point, right, you get a tick mark saying, right, this is ready for production now, right? And then what does the continuous deployment system do, right? It handles two things, right? Which are provisioning and deployment. So your continuous deployment system, right, may not deploy direct to production, right? So in most cases, your continuous deployment system deploys to what's known as staging, right? So continuous deployment, right, to a staging. And staging is what's used for your quality assurance, right? So what happens here, right? First of all, you got to provision some new resources to run your system, right? What you don't want to do is do this, right? You have your production system P1, which is running now, and now you have or PN, right? The nth version of your production system, you have PN plus 1, right? What you don't want to do is shut this thing down and then bring this thing up and then make all of your customers angry because they find some bugs here, right? Or even, yeah, equally bad is, okay, you bring this thing up on different hardware and then immediately shut this thing down, right? So this is not the way that you can do actual deployments in the real world, right? So what do we want to do instead? We want to provision some new resources, right? So these what kinds of resources are we talking about provisioning, right? We may provision virtual machines, right? Databases, what else? Other kinds of storage, right? So-called blob storage, right? Blob or key value, right? Storage, and so on. These kinds of resources for putting the new system into staging or production. It may be staging.
Hello.
You may later use this continuous deployment system to also push this into production itself, right? So first you want to provision these resources,
Hello.
and this is where cloud computing comes in, right? So initially, actually, I was thinking of doing this talk on cloud computing, but then I realized you don't understand the big picture where cloud computing fits in. You miss some of the key ideas there. So now you have a CD system, continuous deployment, right? Which is doing provisioning, right? And nowadays, what does it mean to provision, right? It means provisioning virtual resources, right? We are not actually going to bring up physical servers anymore, right? This is very rarely done in industry nowadays. Pretty much everything has moved to cloud computing due to the cost and labor savings, right? So what do we do when we are provisioning cloud systems, right? These cloud systems all have APIs, right? So they have provisioning APIs, right? And you can call these APIs and create new resources, right? Whatever you need, virtual machines, storage, whatever you need, right? And to do this, right, we have basically provisioning tools, right? And this is commonly referred to by this rather terrible acronym called infrastructure as code, right? So infrastructure as code simply means that you have a configuration file, right, in a language that a configuration tool can understand, right? So you have provisioning tools or configuration tools, they're called configuration management tools, right? Right. That is going to take a configuration that you have written, right, and do the actual provisioning for you, right? It may provision a database, right? It may provision virtual machines, right, and so on, right? So that is the first step of the continuous deployment process, right? The provisioning, which is facilitated by cloud APIs, right? And this infrastructure as code tool or configuration management tool takes a configuration description, right, in various languages. So each one of the cloud providers has their own configuration management tool, right? And there are cloud independent configuration management tools as well, right? So an example of a configuration management tool is CloudFormation. For AWS, right? And there are similar tools for Azure, Google Cloud Platform, and so on, right? And there are also platform independent ones like Terraform, for instance. Right? So these tools basically take a description of the resources that you need. I need this many virtual machines. I may need this many databases. Populate the database with these schemas and so on, right? It does all that. And now it's ready. You are ready to deploy your software, right? And when you're deploying your software also, you might use various deployment strategies, right? Like I said, you don't want to immediately cut over from production version N to production version N+1, right? You don't want to immediately cut over, right? What you instead might do is, for example, there are many such deployment strategies, right? One popular one is known as a canary deployment, right? So canary deployment means you keep some of the old production systems running, right? And at the same time, in parallel, you deploy the new version, right? And you direct some of your traffic, let's say 10% of your traffic, to the new system, and let 90% go to the old system, right? So there are ways to do this. At the front end, you can have a load balancer, right? And this load balancer can be programmed with there are programmable load balancers where you can do these kinds of canary deployments and say, okay, send 10% of my traffic to this new instance of my production environment and the 90% to the old instance. What do you do then? The site reliability engineer monitors both of these systems. The operation team monitors both of these systems and compares the two, right? What about are there any unusual errors, high latency spikes, right? The load on the system and so on, right? They compare just with the 10% of the traffic. The idea with the canary deployment is that if something goes wrong, only 10% of your customers are impacted, right? And you can quickly pull it out and redirect all your traffic to the old system. Sorry, this should be the other way around, right? So send 90% of your traffic to the old system and about 10% to the new system, right? You always send less traffic to the new system than the old system, right? Meaning that you lower the risk of causing a lot of your customers to be unhappy. Okay, right. So this was the second part of my talk where I wanted to give you an overview of the technical aspects of modern day configuration management, right? This whole idea of infrastructure as code, which is enabled by cloud APIs, and how it ties into the entire deployment lifecycle, right? Okay, and I don't think I have a lot of time left. Let me just check. Yeah, I'm almost at the 1 hour mark. So I want to leave some time for questions as well. Let me briefly touch on one more topic, which is observability. Right. So once you have your system in production, you want what's known as observability. Right. In other words, you don't want your boss calling you early morning at 6 a.m. and telling you the system is down. What's going on, right? This is not what you want. You want proactive maintenance or mitigation of problems, right? So we can think of three things. Right? These are not new. These have been around for a long time, right? This idea of alerting, right? Or in other words, health checks, right? Monitoring, logging, and The new one is called tracing. Right. So alerting is very simple. The idea is that, yeah, you have some system which is constantly checking every, let's say, couple of minutes to see whether your system is up, right? Is your system up, right? Because it's okay. If your system is down, then there may be a hardware problem, a networking problem, a software problem. You have to find out, right? When you're alerting in large systems, again, these SRE teams like Google, they have a lot of recommendations around alerting, right? And the main one is not to overload people when things go wrong, right? So if you have 1 million machines, right, and 10,000 of them go down, you don't want 10,000 alerts coming to your phone, right? Instead, you want one single alert, hopefully, that tells you thousands of machines are down, right? So that is about alerting. It's fairly straightforward. It's been done for a long time. Then let me talk about monitoring. So monitoring ties into SLOs, or rather SLIs, right? The service level indicators, right? Things like latency, right? How much latency are customers experiencing, right? You may want to check CPU use, memory, IO, various things, right? All of these things are things that you might want to monitor, right? I want to make a very quick distinction here between SLIs and these kinds of other metrics, right? So these are like system metrics, right? In other words, your end user is not interested in these kinds of things, right? Your end user is not interested in how much CPU, memory, or IO your system is using, right? But your end user is very much concerned about latency, right? So when it comes to service level indicators, it's all about metrics that your end user is interested in, such as latency and error rates and so on, right? Okay, but you may want to log system metrics for obvious reasons. When something goes wrong, you want to look at these things, right? Then the next important thing is logging, right? And this is where operations and development comes together, right? If you don't have a good understanding of operations, things like logging, you learn it, let's say, a little too late, right? These are really fundamental things nowadays when it comes to deploying production-ready software. You can't deploy a production-ready system if you don't have proper alerting, monitoring, and logging, right? So logging is fairly straightforward. Logging is basically your application telling you what it's doing, right? And especially when things go wrong, it should tell you what went wrong, right? Don't say something went wrong, right? You should say what went wrong, right? Which with as much information as you can, right? I try to allocate, right? I try to allocate 1 GB of memory, yeah, but it failed. Right? This is much more interesting than logging, yeah, malloc failure. Okay, so this is not the way to do logging. You have to provide as much information as possible to people in production when you are designing logging into your system, right? The final thing is tracing, and I will maybe, if there's interest, I will talk to you more about this in future. But the basic idea is that nowadays we don't have what are known as monoliths. Like the monolith is the 3-tier architecture where you had the database, you had your business logic running inside an application container, right? And you had your front end, right? Your front end talks to your business logic talks to your database, and yeah, gives you back a response, right? So this architecture is pretty much going out of use because, again, this pressure to bring in more features, right? It's all about the business pressures of time to market, right? Your competitor has put out a new feature. Now you want to catch up with them. So you have to put out that feature as well, right? So because of this reason, we have in software what's known as Conway's law. Right? What does Conway's law say? Conway's law says that whatever software you build, right, your software structure, right, the design of your software, right, the modular structure of your software is going to reflect your organizational structure, right? So if you have two teams building a piece of software together, there will definitely be two different parts of two different modules with distinct designs and so on, right? So there's no way to get around this Conway's law, right? So the idea is you embrace this idea, right? And you empower different teams to build their own services separately, right? So from here, we go to this idea of microservices. Right? And the idea behind microservices is that, yeah, you break this thing up, right? You break it up and you give each team their own service, right? So now instead of one big chunk of biggest business logic, you have this different small bits of small services, right? They may be all talking to different databases, right? Most often you don't share a database anymore. Each one of these services is talking to a different database, right? And they may be talking to each other, right? And finally, fulfilling the user's request. Right? And when you move from this architecture, why did I mention this? Because when you move from this architecture to this architecture, doing only these three things is not enough, right? You need to do an additional thing called tracing, which is, yeah, where this request that originated from the user, right? When it goes wrong, you want to know exactly what path it took through the system, right? This one particular request, where did it go wrong in this system? Because there may be hundreds, or even in the case of organizations like Netflix, they claim that they have thousands of microservices running in production, right? So you really need to know, right, not just individual metrics for each one of these microservices. Individual logging, individual metrics is fine, right? You need that. But in addition to that, you need to be able to trace one request across this whole graph of microservices. Right? Okay, so that was my final topic, observability, right? And now, yeah, just to summarize, right? What are the things I talked about? These two cultural shifts in operations, going from traditional systems administration to this idea of DevOps, where you have more open communication between development and operations, and site reliability engineering, where you define your error budgets very clearly, right? And you eliminate toil via automation, right? There's a big focus on automation and observability, right? So these two movements, DevOps on the one hand and SRE on the other, have really, I would say they have really revolutionized operations, right? And it's an exciting time to be here. If you Google the 2020 Stack Overflow, right? I'm sure you're all familiar with Stack Overflow. If you Google the 2020 Stack Overflow survey, right? And look at salaries, right? Across the world, these SRE and DevOps jobs are close to the top, right? Which is surprising considering that all of the hype is around machine learning, right? So I would expect machine learning, data science, I always expected these to demand the highest salaries, but it seems that there is a real shortage in these kinds of roles, right? And actually, one of my batchmates from WSO2, who's a senior tech lead on the cloud team there, he says that although they have vacancies, they have very few applicants because most people don't even know that this kind of area exists, right? What is a problem in Sri Lanka is that a lot of organizations don't have operations teams, right? So the ones I'm aware of are WSO2, Pearson, and London Stock Exchange. These are the ones who have sizable operations teams. There may be others that I'm not aware of. But that doesn't mean that there isn't a demand for these jobs, right? There's plenty of demand. Okay, so that concludes my presentation. And now, yeah, although I'm a little bit over time, If you have some questions, I could try to answer them. So you can type in chat or you can use the audio.
Can I answer questions? Yeah.
Yes, please go ahead.
Yep. Now, if you are like advising fresh graduate to pursuing this direction, so how particular person can start? I mean, like, so you don't have a control over it when you just starting.
Yeah, correct. So this is actually one of the points that I wanted to, that I hoped would be raised in the discussion. And we actually, from a theoretical point of view, we cover a lot of things in our curriculum, right? So what is required to do these kinds of things that I talked about? Things like on the technical side I'm talking about, right? Things like continuous deployment and automation and those kinds of things, right? So a lot of these things are covered in our curriculum. But what's required is, we cover them from a design point of view, right? Let's take operating systems, for instance. We talk a lot about the operating system, right? The design of the scheduler, the design of our virtual memory system, and so on, right? What we don't have is, in practice, right? How do we analyze these kinds of subsystems in an operating system, right? When something goes wrong and you want to troubleshoot, let's say your program is eating up too much memory, right? You look at the code, you can't find it out, right? But we have really good observability tools, especially on Linux nowadays, where we can use those tools while the program is running to analyze it and try to identify what the program is doing, right? So I think from a curriculum point of view, we have all of the ingredients in our curriculum. It's a shift in the focus from like talking about only the operating design and implementation of operating systems to how you can use operating systems as a tool for analyzing your running software, right? So I know that, for instance, the most basic thing would be to introduce students to things like debuggers, which we already do, right? So, but the role of debuggers is quite different in production versus software development. In software development, it's just a tool that you use to gain some insight into a logic bug that you have introduced in your code, right? But in production, a debugger's role is quite different, right? You're breaking into a debugger to try to quickly fix a problem that is in already deployed code, right? Maybe you don't have the option of patching it right now for various reasons. So you need to look at the running code, see what it's doing, and try to mitigate the problem for the time being at least, right? So again, I think our students have a good background in these kinds of things. Maybe we can add a little more focus in our new curriculum towards these aspects. But mainly, I think we need to change the focus in how we teach some of these subjects like operating systems, where we start to look at operating systems, not just from a design point of view, but as a tool that we use every day. Right. So when it comes to starting in your career, I think, like I said, the organizations that I mentioned earlier, Pearson WSO2 and the London Stock Exchange, these are the ones with the largest operation teams that I'm aware of. There may be others that I'm not aware of. And if you like systems, right? Systems meaning topics like networking, right? So networking, you need to have an understanding of networking protocols, for instance, right? To debug latency issues, right? It may not just be the system, but there may be networking problems as well. So you need to understand some of the networking stuff as well. right? So if you have a love of systems and systems related topics like operating systems, networking, and so on, then this is an ideal area for you to go into. And there are a lot of sub areas here in operations, right? There are areas such as cybersecurity, right? So focusing on the security aspects, there's performance engineering, which focuses on improving the system performance. There's data engineering to handle so-called big data systems, right? And so on. Any other questions?
Yeah, does this have much radical effect on software development life cycles?
Yes, it does, Dr. Santingama.
Yeah.
So like I said, when it comes to software development, the biggest impact is in enabling observability. Right? So this is something that pretty much no software engineering, the traditional software engineering textbooks, I've never seen them discuss this, right? They just talk about traditional waterfall life cycle, like they talk about agile and so on, but the traditional waterfall steps, requirements gathering, design, implementation, and then they talk about so-called maintenance, right? But there is no such thing as maintenance nowadays, right? It's a constant, like I said, it's a constant cycle where development pushes to production, right? And production informs the development, right? So it's a very rapid cycle that basically agile, it's where agile has incorporated production, right? And this is essentially DevOps. You incorporate the production aspects into agile. That's what you end up with as DevOps.
So will that knowledge become obsolete and there's no use of teaching all of them in the future? Or
Which knowledge exactly, Dr. Sandhu?
I mean the traditional development methods.
So one thing I can say about, I wouldn't say it's obsolete, but some things have become less important, right? So like I said, when we are moving from the monolithic architecture to these microservices, right? So each of these microservices is a fairly tiny thing, right? So all of the massive effort, design effort that you need to put in to build a nice monolith, right? To make it nice and maintainable and so on is less relevant here, right? I'm not saying these things are completely irrelevant, right? But a lot of other things have become more relevant compared to, this traditional design aspects that we're talking about, right? We're always emphasizing object-oriented design. For some reason, our software companies are still asking these things at interviews, right? About, what is inheritance, what is polymorphism, and so on. And all of that becomes much less relevant. You're right. It becomes much less relevant in this environment.
So obviously now what you talk, is mostly applicable in, large systems. So like if somebody develops, very small systems, still will it be applicable what you talk today?
Yes, I would say some of it is applicable, not everything, right? So if you're just developing a small startup and you want to just get a few customers to start with, right? Most people would not recommend going with full microservices architecture and so on, right? It's going to add too much overhead, right? So the common thing that you do is you always start with a monolithic application, right? And as you grow, at some point you decide, okay, to keep responding to business demands, right? To new business requirements, we need to move, because of Conway's law, we need to move from this monolith to microservices, right? So to give you an example, I worked for a big intercity bus operator called Flixbus in Germany. And they had, they started operations only in 2013, but they grew massively within 5 years to become the largest operator in Europe. And they had a big monolith, right? And they were in the process, because they recognized that this monolith is slowing them down, right? They want to introduce new services all the time. new value-added services and so on. So they found that this is holding them back due to Conway's law again, and they wanted to move to this microservices architecture. So this is what you see in a lot of companies. It's not that, yeah, you just throw away this old way of building software, but rather, right, at some point, almost all organizations find that this monolithic structure is constraining them. From a business point of view, this is slowing them down, right? And then they move to this architecture. And one other point I would like to make is, even if you have a pure monolith nowadays, right, even if you have a pure monolith like this, you are still reliant on a lot of external services, right? You may delegate authentication to Google, right? You may have a sign in with Google option, right? Or yeah, another third party. You may be sending out emails to your subscribers, right, or to your users, and that may be a third-party service. You don't want to run your own mail server, right? So pretty much everything outside of a database, right, will be an external third-party service, right? So this whole idea of yeah, the old name for this was service-oriented architecture, right? So the same thing taken to its logical conclusion is what microservices is, right? So you rely on external services, and then you look at your own monolith and decide, okay, this can also be broken up into such services. Any other questions?
When you're shifting from this monolith to microservices, you have to do it everything from the scratch, right? Or can you use something that you used before?
It depends really. In some cases, people may decide, now in the case of this company that I work for, what they did first was not actually break up the monolith, right? When they had new requirements, whenever they had a new requirement, they decided, okay, we'll not add it to the monolith, but we'll design it as a microservice, which interacts with this monolith for the time being, right? And this gives them the experience in building microservices, right? Once the team has developed this experience of building microservices, then they go in and look at, okay, what are the pain points here, right? What are the parts of the monolith that are being changed all the time, which impact business requirements the most, right? And try to extract that code out into a microservice. So that the idea is that the team that owns that part of the business logic can independently develop that and not be completely tied into this monolith, the development cycle of the monolith, right? So
what about something like hybrid, like monolith and microservices? Can you have a hybrid kind of system?
Exactly. That is exactly what I was saying, right? So you don't have to immediately go do a big bang thing where you completely abandon this and go to this one. It is a gradual migration that you see in most companies. And that is actually the right way to do it, right?
No, even at the end, you don't have to completely take the monolith. You can, I mean, forever work hybrid, right?
Of course,
yeah,
certainly possible.
Yeah.
And I'm pretty sure some companies, yeah, do it. Any other questions? Any other topics that you would like me or to find people to cover? I could cover, or some other people could cover as well. So one one area that's supposed to be really hot right now that I've heard is Dr. Ramesh Ranavana, who used to be the director of or chairman of SimCentric. He now has a new company that's developing unmanned aerial vehicles, UAVs, for various applications, and they are doing a lot of machine learning. So he is talking about, or he was telling me about this new area called ML Ops. Right. So hopefully I can maybe convince him to do a talk at some point about this. So machine learning, we again look at it purely from a development point of view, where we are developing machine learning models, but there's always the other side of it where we put these models into production, right? And apparently that is a very in-demand skill right now. Any questions from instructors or students? Okay, I don't see any questions in chat. Let me just double check. Okay, I think there are no further questions. So I would like to thank Dr. Samarkon for and also Sampath for letting me use the facilities in the AV studio. So as you might have noticed, I'm using this light board. It was built at the engineering workshop. Vasundar got it built for me. And it's here now in the AV studio for anybody to use. So yeah, I think it's a nice alternative to doing the traditional kind of slide presentations. So if anybody likes to use it.
How does it work, by the way?
So basically, it's a pane of glass with LED strip all around it, right? And so if you use a fluorescent marker, actually, we can't find the fluorescent whiteboard markers here, but yeah, I used a highlighter, which is not ideal. But then it basically lights up the LED. Yeah, it's basically refracted into the glass, and it lights up whatever you write. So Bandara in the AV studio, he's familiar with the entire setup. We also managed to get this Canon DSLR camera, which gives you like really good resolution as well. So it works as a webcam now. And yeah, you can try this out in the next semester.
Can you project the slides onto this? Can you have your slides on this and write on them while you are teaching?
I have seen people do it, but to be honest, I haven't looked into it. So I found an article that explains how to use this as a second camera in Zoom. So I think there may be a way, but always you can also switch, right? You can. So this is your webcam basically that's pointed at this board. And you can always switch to your screen sharing mode and share some slides in between.
Oh, okay.
Okay, thank you very much, everyone. And like I said, we are hoping to have this as a continuing series of talks where we have 2 talks every month, every 2 weeks. And yeah, already Dr. Sandrigama and Janaka have volunteered, Dr. Alavatagoda have volunteered. I hope we'll have more volunteers within the staff. And I encourage the staff also to contact whomever you have in industry, your contacts in industry or academia, and ask them if they can give us a presentation for this seminar series, right? And I would especially like to invite also the instructors and postgraduate students to also have a research talk, if you'd like. And yeah, we'd really like to see more of that as well. Okay, so thank you everyone for your time. And I hope to see you next time.